Eddy current. Okay, now we discuss eddy current.
We use an apparatus that allows a copper plate to swing back and forth through a
It is
magnetic
audible.
field
Hello.
like a pendulum.
Yes, sir.
Swing forth through a magnetic field like a pendulum. The plane in which the copper plate swings is parallel.
Hello. Wait, it's audible or not?
Audible,
Yes,
sir.
sir. Audible.
It is
The
audible,
plane of
sir.
the plate and normal to the direction of the magnetic field. As the copper plate enters the field, the changing
Hello.
magnetic flux induces an EMF in the plate, which in turn causes the free electrons
Students,
in the
it is
plate
audible or not?
to move,
Sir, yes,
producing
sir, it's
circulating
audible.
eddy currents. Note that the magnetic field is directed from the north pole to the south pole of the magnet that provides the field. Through a magnetic field, like a pendulum. The plane in which the copper plate swings is parallel to the plane of the plate and normal to the direction of the magnetic field. As the copper plate enters the field, the changing magnetic flux induces an EMF in the plate, which in turn causes the free electrons in the plate to move, producing circulating eddy currents. Note that the magnetic field is directed from the north pole to the south pole of the magnet that provides the field. When viewed from the north pole side of the magnet, the induced eddy current is counterclockwise as the plate enters the field. As the plate enters the magnetic field, the external magnetic flux through the plate increases. Hence, by Lenz's law, the induced current must provide effective magnetic poles on the plate that are repelled by the poles of the magnet. Thus, here a north pole is induced over the surface of the plate facing the north pole of the magnet. As the plate leaves the magnetic field, the external magnetic flux through the plate decreases. Hence, again as per Lenz's law, the induced current must provide a magnetic south pole on the surface of the plate facing the north pole of the magnet. This is quite opposite to the case when the plate enters the magnetic field. The induced eddy current always produces a retarding force FB when the plate enters or leaves the field. This retarding force slows down the swinging of the plate and eventually brings it to rest. Thus, the oscillations of the plate are damped. When rectangular slots are cut in the plate, eddy currents and the corresponding retarding force are greatly reduced. This reduction in the retarding force is because the rectangular cuts in the plate prevent the formation of large current loops. Hence, the pendulum plate with holes or slots reduces electromagnetic damping and the plate swings more freely. Let us now explore the uses of eddy currents. Eddy currents are produced when a metal plate is subjected to a changing magnetic field, heats it. Hence, these currents are unwanted in certain situations. Reduction in the surface area of the plate helps in reducing eddy currents in the metallic cores of transformers, electric motors, and other such devices, in which a coil is wound over a metallic core. Eddy currents are minimized by using laminations of metal to make a metal core instead of using a single metal piece. The laminations are separated by an insulating material like lacquer. The plane of the laminations is arranged parallel to the magnetic field such that it cuts across the eddy current paths. This arrangement reduces the strength of the eddy currents. Since the dissipation of electric energy into heat depends on the square of the strength of the electric current, heat loss is substantially reduced. Let us now study the applications of eddy currents. Strong electromagnets are situated above the rails in some electrically powered trains. When the electromagnets are activated, the eddy currents induced in the rails oppose the motion of the train. As there are no mechanical linkages, the braking effect of the train is smooth. Certain galvanometers have a fixed core made of a non-magnetic metallic material. When the coil oscillates, the eddy currents generated in the core oppose the motion and bring the coil to rest quickly. Induction furnace can be used to produce high temperatures and can be utilized to prepare alloys by melting the constituent metals. A high-frequency alternating current is passed through a coil which surrounds the metals to be melted. The eddy currents generated in the metals produce high temperatures sufficient to melt it. The shiny metal disc in the analog type electric power meter rotates due to eddy currents. Electric currents are induced in the disc by magnetic fields produced by the sinusoidal varying currents in the coil.
Sir, you are on mute, sir.
Now it is audible. Hello.
Audible, sir. Yes, sir. Now audible, sir.
Yes, ma'am. Tomorrow morning for you physics revision exam test 1. Okay, it is a normal. It is not a very difficult one. It is a normal test only. Chapter number 6, Electromagnetic Induction. You can remember all the formulas, all the SI unit, constant value, and the principle and applications. Okay, tomorrow morning. So in this mark, we consider for the term 1 internal assessment. Okay, so before you completed English exam completed, next maths also completed. Okay, but for physics and chemistry and biology not like that. So the upcoming days we'll get two periods: physics 2 periods, chemistry 2 periods, biology 2 periods. So in this month of August, we should conduct 4 tests, 1 practical test, 1 full test. So overall 6 tests. Chapter number 6, Electromagnetic Induction, test 1, test 2. 2 tests also, chapter number 6. Okay. Test 3 and test 4, that is a alternating current, AC lesson. So that one I will tell you after. And the practical syllabus, experiment number 1 and 2. Ohm's law, another one meter bridge in series. 2 experiment. This is for you. Upcoming week schedule. Okay. Tomorrow onwards. So tomorrow morning 6:30 for you test mark chapter number 6 electromagnetic induction. It is Google form. Not a Google form, it is a MS form. Okay, you can use your username password properly, then only it is possible to write. Any other doubt? Chapter number 6 electromagnetic induction. What are the areas we completed? That alone. Everything we completed, but you don't basic level. Okay, it is like a easy paper. Next test it is difficult. So tomorrow means it is easy. Clear? Vishwesh Kumar, did you understand? Manisha, Navin Raj, hello. Anybody give me reply? Did you understand?
Yes, sir.
Yes, sir.
Yes, ma'am. Tell me, ma'am. Your voice not clear now. I am also today facing some network problem. MCQ only, assessment and reasoning type method. Another one MCQ method. 20 marks. Tomorrow morning 6:30 exam. Okay, now your voice not audible. Hello. It is easy definition now. Just note it. The eddy current definition. Eddy current are the current induced in the solid metallic masses. The current induced in solid metallic masses when the magnetic flux threading through them changes. So magnetic flux changing means the induced current also producing. Please note it. The current induced in solid metallic masses when the magnetic flux threading through them changes. Okay, so this is the definition about eddy current. Please note it. The uses of eddy current: electromagnetic damping, electric brakes, speedometer, induction motor, electromagnetic shielding, inductothermy, energy meters. So these are the uses of eddy current. So how to reduce that eddy current means using laminated core like a choke. A tube light, it is an inside the tube light, that old method, the square box like that, it is a, okay, it is called as laminated core. The applications of eddy current, please note it. Next one, electric brake, electric power meters, fifth one, electromagnetic damping, that is a galvanometer. electromagnetic damping. Okay. And one more also there, electromagnetic shielding. Sixth one. So inductothermy. Inductothermy means in our human body tissues, it is that tissues temperature, that heat also we can localize it. So which area the heat it is the measuring purpose we are using the inductothermy. That study is called as inductothermy. Heat localized tissues of the human body. Inductothermy means heat localized tissues of the human body. This branch is called as inductothermy. Metal name aluminum. Electric power meter, it is they are using for aluminum disc. Please note it, that is the aluminum disc. And eddy current, it is using for the speedometer also. That any magnet rotates according to the speed of the vehicle and produce the requiring change in magnetic field. So here also they are using aluminum drum. That specific is important. Aluminum drum we are using.
Sir, should we write these explanations for the application, sir?
Now no need more. Before they ask 5 more questions, you want to write. So now only for the MCQ method, no. That specific column we can mention, but underline alone. Induction furnace means height, producing high temperature. Speedometer we are using for that aluminum drum. That underline part alone, please note it. For smoothing purpose, applied smoothly the brakes. Inductothermy means the heat localized tissues of the human body. Faraday's law, induced EMF, Lenz's law, eddy current, self-induction and mutual induction. Chapter number 6 syllabus, that's all. So what is eddy current and applications of eddy current? Next, self-induction and mutual induction. Mutual inductance means what? Self-induction definition. And mutual induction definition formula. And one of the application for the solenoid. Self-induction application solenoid one, another one mutual induction also solenoid is there. And Faraday's first law and second law, induced EMF and induced current, that formula. So this alone you can prepare for tomorrow exam. Okay, just a minute, I will confirm tomorrow morning or tomorrow evening. I will confirm. Okay, I will get permission from John sir. Ma'am, my voice is audible, ma? Hello?
Yes, sir.
Yes, sir, audible, sir.
Audible, ma. Thank you, ma. So tomorrow evening, 6:30 for you test. Okay, chapter number 6, electromagnetic induction. Tomorrow evening test. Clear? Tomorrow evening or tomorrow morning, which is your convenient?
Evening, sir.
Evening, okay, sir.